Hello, everyone. In this lesson, we're going to talk about solving cosine equations. And of course, as always, we start with simple. So we're going to talk about simple cosine equations, that if statement. Previously, we have talked about solving simple sine equations and any sine equations. So we're going to follow the same, approach. And of course, we know that definition of function, right? In the case of solving equation, that if statement is made in such a way the output is given. The output is given. And in the trig function case, right? Let's start with ARD, right? Let's review what ARD. A is for angle measurement. Okay, a positive angle is measured counterclockwise from the standard position. And a negative angle, of course, is measured clockwise from the standard position as well. So the measurement is something we're very familiar with, okay? And the R, okay, is the positive acute angle between the terminal and x-axis. Okay, so ARD, T is about definition. For definition, we talk about how we set the stage to define all 6 sine functions, all 6 trig functions: sine, cosine, tangent, cotangent, cosecant, secant. And today, of course, our focus is cosine. Okay, so x comma y is a point on the terminal side of an angle, and we call this angle A, okay, which is measured, okay, in the way that we just specified. So this is any point on terminal side of the angle, and we call it A. But we have another very important specifics. I believe you guys don't forget, right? Other than the origin. So this guarantees that the R, which is defined as such, x squared plus y squared, will always be positive because x and y are not equal to 0 at the same time. And of course, we know cosine of this angle is equal to x over r. Okay, in our color-toned explanation throughout this course, x is the red, right, the horizontal measurement, and the y is the blue, right, x, y. So all of these points on unit circle are, examples of a point on the terminal side of the angle other than the origin. And we understand that for special angles, and these points are listed on the unit circle, but there are also numerous and infinite number of points that are not listed, which also has a red and blue. We understand that. Now, let's go back to cosine equation. What does a cosine equation mean? Cosine equation means that for this function, okay, input is angle, and the rule of the function is, of course, cosine. we follow the rule of cosine. Whoops, what did I do? Oh, okay, never mind. The rule of cosine, right? It produces the ratio. So the product is a ratio. Okay, the rule of the function and that the output is ratio. For if statement, for cosine equations is that we know the output and we're looking for the input. Okay, we know the output and we're looking for the input. So the if statement is that the output is given. And we want to find all possible inputs. And where do we find all possible inputs? And of course, inputs are from the in the domain of cosine. What's the domain of cosine? All real numbers. Okay, so let's look at some examples and then we talk about the interpretation. Okay, example. Typically, these kind of questions will be given as such. Okay, solve for A. Okay, I'm going to use A in this case, where cosine of A is equal to √3/2. What does that mean? The meaning is that it's in the same context as we just said, right? We don't know the angle, but we know the output. We know that all the angles will give us this output, and that output is such. And of course, that's so immediately you recognize X is √3, R is 2, right? So that's one way to identify this question and identify the nature of the question. And what is our objective? Objective to work out this question is to find all possible inputs, and inputs are angles, right? Inputs, such that the statement will be true for all of those inputs, right? So we talked about the graph before, and we talked about the graph before, and we know the making of cosine curve, and we know the unit circle very well. So if I put in the curve in the picture right here, okay, so the cosine curve is right, it's like that. Okay, so now how do we solve this cosine equation? Well, this is a special. There are a couple ways to solve this. So I'm going to show you these different perspectives. Okay, of course, I have other examples out there. Okay, so let's just look at this one, nice and clean. Okay, the first way to solve this is we just look at the unit circle. We look at the unit circle, we want to find what are the terminals with the red ratio, right? Do we find one? We found two. We found there's one here. Okay, we found one here. Okay, which the angle is pi/6. And we found another one, -pi/6, that terminal, right? So we have pi/6 and -pi/6. We have other terminals that will give us the same ratio, the same output. No more. And therefore, in this case, the solution would be positive or -pi/6. Okay, and plus 2k pi. And k, of course, would be any integer. So the problem is solved. Okay. Is this the only way to represent solutions? Of course not. Okay. So other forms of solutions. Right, but this is the simplest way. To me, this is the simplest way. You just identify the terminal, and the solution is right there, okay? Other forms of solution, of course, you can write it down in a similar form as we did. So let me just make some adjustment to the picture, okay? You could write it down in the form that's similar to the sine form, okay? To the sine, okay? You have the first, you identify pi over 6. So you have pi over 6 plus 2k pi, right? And you can also identify the other terminal as 11 pi over 6, 11 pi over 6, right? And plus 2k pi. Okay, so let me measure for you, okay? Pi over 6 is the terminal which we measure from the standard position, which terminates here. And the other one will be measured counterclockwise, go around almost, and that's 11 pi over 6, right? You ended up on the same terminal. So we use negative pi over 6, it's the same thing, it works. And besides, remember, cosine is an even function. If you have a solution that's positive, you have another solution that's a negative because it's an even function. It's an even function. It's different from cosine, okay? So at this point, you may like to take a break and look at the solving of sine equation. You can see the difference. You can see the difference, okay? And the k, of course, is integer, okay? And there's many different ways to solve this equation. So this is the first way, right? The first way, we use unit circle. Okay, so method 1. Okay, use unit circle. Or use definition, use unit circle, right? The second way, method 2, you can use a curve. You can use a curve, right? So we have the curve, we know the output. Output is root 2 over 2. So I can draw a horizontal line. I'm going to draw a horizontal line. Okay, I'm drawing this horizontal line. Okay, it cut the curve at 2 different places in the picture, but there are many other places if I show you more of the picture, right? Because we know the picture goes on and on forever. Okay, so let me give you a little bit more, right? You can see there's all these solutions. There are all these solutions, okay? So how do we represent these solutions? Because of symmetry, you can see, okay? So this piece, okay, which is the arc length, we use orange, right? That arc length, we use orange. And so this is orange, that's arc length, pi over 6, and that's negative pi over 6. You can see, and they both have the same height, root 3 over 2. And then if you take this point, right? If you take this point, and if you take this point from here, hold on, let me show you what adding pi plus pi minus pi means, okay? Suppose we're on this piece, right? This is a pi over 6. This point is pi over 6, okay? And if you add 2 pi, okay, you get another pi over 6. You get another number. Okay? Between these two, okay, that's 2 pi. That's 2 pi. Okay? And for this piece, okay, I'm going to mark it with a star. So this is a star. And of course, we know this is negative pi over 6, right? Between this star and the next star, and these two, between these 2 stars, that's another 2 pi. That's another 2 pi. Okay, so you can keep going in both directions. That's the description of all the solutions. That's a description of all the solutions. Okay, and this is hard, and there'll be another heart if we just do a little bit more, right? So this piece will be the heart. If you, and between these two hearts, and that's another 2 pi. That's another 2 pi. And between another star, so this is a star, and so between the stars, and that's another 2 pi. Okay, so that's 2 pi, and that's 2 pi. Okay, so we have, once we identify the terminal, we just add 2 pi, subtract 2 pi in either direction, and you'll get all the solutions. So that's using the curve. Okay, that's using the curve. Okay, and using the curve, because it's an even function, you have a solution on one side, you also have a solution on the other side, right? So that's why this form is the most straightforward. Okay, so when we use the curve, use a cosine curve, you draw the same conclusion. Okay, so that's how you can see we like this way very much. Okay, the third way, would there be a third way? Of course, we can use a definition because this question is from D to A, right? We know the ratio and we want to identify the A. Pretend that this angle is not that special angle. We don't know what it is. Okay, so we do a little pretending. But why we talk about this method of pretending? Because we're going to talk about how to solve cosine equations that are not special, that doesn't correspond to special ratios. Okay, we're going to use definition straight. Okay, so it's ARD. So from D to A. Okay, so from D to A. So how do we do D to A? Right? And then we're going to introduce a rectangular system. Okay, so if you like, this will be best if you, well, let me clean this up. Okay, I'm going to clean this up. Because I'm gonna be moving the pictures. Okay, so they're going to make a mess. All right. So I'm going to start the rectangular system, which is a stage set, right? Which is a stage set for our ARD. Okay, ignore that y equals 0. It's just initiate. It just initiate the value. Okay, just initiate the rectangular system. Sorry. So this is a negative. So I'm going to make it -3, +3. -3, +3. Okay. So I'm in this picture, right? We're pretending. We're still solving it. Of course, I'm going to bring that question with us, right? By definition, we know √3/2 is what? Is x over r. Is x over r. So x is √2. I'm sorry, x is √3. Okay, so that's from D to, we're going to go from D to A, right? So x is √3, r is 2. R is 2, right? Well, x is 3, so the red number is a 3, so I'm going to draw a red. Okay, you guys draw that too. Okay, √3. And that's the red piece. That's the red piece. Okay, let me make the red piece thicker. Okay. Well, now x is root 3 and r is 2. R is 2. And it would be nice if we know the blue, right? If we know the blue. And can we find the blue? Of course we can find the blue, right? The blue is r squared minus, so we can find the blue by using the Pythagorean theorem. Okay, so I'm going to draw the picture briefly right now, but we have to draw it on the using the same software. So it's just going to be, this is the hypotenuse, and we need a piece of blue. So we're trying to identify the blue. Does that look like a blue? It's kind of dark blue. So let me redo it. Okay. So let's draw the blue. Okay. And the orange color, I think I'm going to change it to black. Okay, I just change it to black. All right. So we know the red. The red is root 3. R is 2, right? So R is 2. Pythagorean theorem tell us the blue will equals to what? What does the blue equals to? The blue equals to R squared, which is 2 squared, minus root 3 squared. Okay. Whoops. Root 3 squared. There we go. And that's going to be square root of 4 minus 3. That equals to what? That equals to 1. Root 1 is equals to 1. There we go. So the blue is 1. Blue is 1. So now, you know, we can figure out that definition, right? X, Y, R, right? So from X and R, we figure out the blue, right? So now we know blue is 1. Okay, so now we can draw a better picture. And I hope you guys do this along my side, right? So the blue, let's draw the blue. Let's see, 0 and root 3, comma, 1. Okay, and that's blue. We want it to be thick. Okay, so we got the blue. So now, of course, we will draw the proper hypotenuse, right? There we go. Okay, so this is a point. So this point, which is x equals to root 3, y equals to what? Y equals to, so let me put it here. Okay, so the red is root 3. All right, let me draw it. Okay, root 3 should be red. Let me get that red. Okay, so root 3 is the red, comma, the blue is 1, in parentheses. That's the point. That's the point. So what we find out is that from that ratio, okay, from we have identified X, we have to identify R. In turn, we identify the blue, and that blue is the, you know, this blue, the number 1, root 3, the red is root 3, and R is 2. It's not on unit circle, but this point is a point on the terminal side of the angle other than the origin. Okay, we will have identified this terminal. Now, for this terminal, right, we can identify the angle. What is this angle? Well, of course, you know the angle, the answer of this angle, right? This angle is going to be one of the solutions. And there are many, many angles that terminate on the same terminal. And now the question is this the only one? Of course, this is not the only one. There will be another terminal on the other side, which is symmetrical, right? With the same with the same red number. And there's another terminal. There's another terminal that will give us the same ratio. That will give us the same ratio. So let's draw the other one. Let's draw the other one. Okay, so let me erase that. I'm going to draw the other one so you can see how we identify all the terminals. That's from DRA. So right now we're working on the R. From the ratio, we work on the bridge, which is a reference angle, right? So the other terminal would be, okay, that's √3. That's a -1. Okay, so this is the other terminal. This is the other terminal. And this terminal can be, of course, go as long as you want. And there will be another blue. There will be another blue. Okay, but this blue is going to be like this. But both terminal will give us the same cosine ratio because they share the same red. They share the same red. And now, of course, what are these angles? What are these angles? Okay, what are these angles? Of course, we know, right? How to find these angles, right? And how do we find this angle? If we know that these two angles are the same size, if you find this angle, you will find this other angle, right? If we call this angle theta, right? If we call this angle theta, what would that theta equals to? I know you're going to tell me that's pi/6, but I'm going to change the way of writing it. Okay, this angle indeed is pi/6, but this angle is also arc cosine √3/2. Okay, √3/2, right? And of course, you know that's equals to pi/6. No problem. But why we do this? Because we want to know how to find solutions for any cosine equation, right? Special ratio or non-special ratio. So this establishes the similarity. If you know how to solve special, you can solve general, any, okay? And of course, our final solution is still the same thing, but this process of analyzing, is instead of writing the solution as pi/6, I'm going to write it as positive or negative arc cosine √3/2 plus 2k pi. Okay, of course, where k is integer. At this point, I hope you guys understand, right, what I'm trying to do. Okay, so now with these three methods specified, we want to see another cosine equation, which is this time is not a special ratio. Okay, so we're going to solve for A, where cosine of A is equals to 4/5. A pretty familiar number. And this time we're going to use all three methods to talk about it. You can see how we can solve it. Okay, how we solve it. Okay. So let's do it over. And this time, I'm going to use the ARD first. Okay, so I'm not going to address these three methods in the same order. Okay, And similarly, similar to what we did, right? Situation we have here. Instead of solving for A, where the ratio is √3/2, now we got the ratio equals to 4/5. So X is 4, R is 5. Okay? And we're familiar with that 3, 4, 5, right? Of course, you can also find the blue. The blue will be 3. Okay? If we use the same method to find the blue, we can do that. Okay, so let's just do it anyway. But this time it will be the 5 squared minus 4 squared. And of course, we know that's going to be square root of 9, and that equals to 3. Right? So we're going to make adjustment to this picture. You can see the similarity, right? You can see the similarity. And this time, what do we see here? Of course, we're going to have to adjust these numbers, right? So let's take our time to adjust those numbers. And so this is going to be, the red is going to be 4, right? The red is 4, X equals to 4, right? So let me, X is 4. Okay, I'm going to make a lot of adjustment. Okay, so hold on, let me just write it down. Take your time, follow me. So X equals to 4, R equals to 5, right? I'm going to make adjustment to the rectangular system. Okay, so -5 to +5, right? And now the red is longer. I'm just going to make these adjustments as needed. So this is going to be 4, 0, 4, 3. So that's going to be my blue, right? And how about the hypotenuse? Hypotenuse is going to be 4, 3. Okay, you can see that it just, if you look at the process, right? If you look at the process, and this is going to be 4, and this is going to be -3, and keep going. And that's going to be 4, and that's going to be 4, and that's going to be -3. There we go. There we go. You see, similar, very similar situation, right? And we still have 2 terminals. So that's D, R. We identify 2 terminals, and these 2 terminals, they correspond to the same reference angle. Now the question is this time it's not a special angle. What would this angle be? If I call this angle theta, and this other angle would be what? Negative theta. So all I have to do is identify theta. So what would that theta be? The theta would be arc cosine 4/5. And this time we don't have a special angle for it, and we just use it. Do we have any other terminals that will give us the same cosine ratio? None, no more. Okay, and therefore solution would be theta, right? You can use theta and plus 2k pi. Okay, of course, plus minus theta plus 2k pi. Okay, where k is any integer. Or you can write it down. If you don't want to introduce theta, you can write it down as follows. You can replace theta by arc cosine of 4/5. Okay, let me see if I made any mistake. Yeah, I think we're fine. Okay. So this is the second, this is the first method. Okay, this is the first method. Okay. So let's see. Yep, that's the first method. Method 2. Okay, so I'm going to clean this up. Oops, I'm going to clean this up. Okay, so you know what theta is. You know what theta is. Okay, I just want to mark it. This is method 1. So we go straight from definition. Okay, for non-special case. For non-special case. Okay, and that's it. And this is the other way to express our solutions. The second method, method 2, we can use cosine. We can use a cosine curve. Okay, we can use a cosine curve. Okay, of course, the cosine curve this time. For the cosine curve this time, the output is 4/5, right? So the output is 4/5. So our horizontal line that was drawn there is not special. It's a it's not a √3/2. Okay, it's a 4/5, right? It's a 4/5. So I'm going to draw 4/5. There we go. So it crosses two places. Okay, it crosses two places, and symmetry, right, is even function. So there's a heart here, and there's a star there, right? And the arc length, which I'm going to use orange, okay? The arc length, this piece, okay? It's not a special length, and this piece is theta. This piece is theta. This piece is theta. Okay, so this star, the coordinate of the star is theta. Okay, theta is the angle, and the ratio. The ratio I'm going to use red is a 4/5. How about this point, the heart, right? The heart here is 4/5 is the output, cosine ratio. Okay, and the orange, that's negative theta. That's negative theta. Okay, and if you identify other places and it has the difference between the two hearts is 2 pi. Okay, that's 2 pi. That's 2 pi again. Okay, for the star, and there's another star, right? Between these two stars is another 2 pi. That's to the left, and to the right, same thing. Okay, so you have a star, you have a heart, there's a heart here, right? So between these two hearts, that's 2 pi. Between the two stars, that's 2 pi, right? 2 pi again. So 2 pi, that's why we add 2 pi minus 2 pi. Okay, so the second method, drawing horizontal line. Okay. All right, so let's look at the third method. Let's look at the third method. The third method, the reason I want to mention the third method is I want you guys to see something that is not visibly there. Method 3, which is a unit circle. On the unit circle, you don't only see the numbers that are there, you also would see the numbers that's not there. Okay. So of course, we're still solving the same equation. Okay, we're solving the same equation, cosine. We know the output, right? It's a DRA question, and we don't know So we need to know that 4/5 is one of the red numbers that's not marked there. Where is it? Where is it? 4/5 is 0.8. 0.8 is between 0.7 and 0.8, blah, blah. So 0.8, so there is a terminal here, right there, right? And there's a point crossing the unit circle, And this point, okay, so let's try to mark this point. This point also has a red, and it also has a red and a blue, okay? And we don't know the red number, well, we don't care about the blue number, actually. We can find out, and the red number is 4/5. That's what it means. And of course, in this case, we know the blue number is 3/5. But we really don't need this. We don't need this. So this is what I meant. You see the unit circle, you see the points that's being marked, you also will see the point that's not being marked, there are lots of points in between. So we need to be able to handle the cases that are special with marked points or non-special with marked points. So 4/5 is right there. So what is the angle? So this angle, we call it theta. And there's another one. Okay, there's another one. And the other one is here. Okay, and there's another crossing. And this point, if we are to mark it, okay, it also has a red. Okay, the red is 4/5. And the blue, of course, we just happen to know it. If we don't, we can find it. We can find out. We don't need it for this question. It's 3/5. Negative 3/5. That's what you can get from the unit circle. Okay. So we have identified the two terminals with the same reference angle. And this angle, of course, is a negative theta. Right? How do we represent theta? Now theta, of course, equals to arc cosine 4/5. Right? So we have a terminal, so that you can see DRA, right? We get to the R, we can identify two terminals. In the end, the solution would be plus minus, right? Arc cosine pi over, arc cosine 4/5 plus 2k pi. Okay, k is any integer. So we've done two examples. One is special, one is not special. And the ratios are positive. Okay, how about ratios are negative? Right? So let's do another two examples. So example number 3. We're still solving for cosine equation. Okay, and this time I have a negative root 2 over 2. Right? And you can use all three methods. But knowing that this is a special angle, right? Then we just look for the negative. So we know the D and we're looking for the R, right? So what are the R's? Well, we're looking for the red root 2 over 2, right? We have two red root 2 over 2. There's one here and there's one here. So we found the two terminals, right? And there's one terminal here and there's another terminal over there. You see? Okay. And how do we find the solution? How do we find the angles? The angles are all measured, the solutions, the input angles are all measured from the same place, from standard position, right? So this angle is theta. And this other angle is negative theta. How do we find theta? Theta is equals to arc cosine. I'm going to give you two forms. Negative √2 over 2. And this is also the same as 3 pi over 4. So you can use either one. You can use either one. So finally, the solution would be what? A equals to plus minus 3 pi over 4 plus 2k pi, where k is any integer. Okay? That's it. You see? Example number 4, non-special cases. One of the non-special case. Okay, so I'm going to have a negative 4/5. Negative 4/5. Okay, for negative 4/5, what do we do? Okay, I'm going to borrow that picture that we did earlier. I'm going to bring this picture, and you guys please draw pictures with me, because this picture has to be adjusted. Everything is going to be turned to the other side, right? Everything is going to be turned to the other side. If we turn to the other side, so let's do the turning. Turn to the other side, right? Everything is going to be turned to the other side. There. More turning. There. Turned. Okay, so we from D, we have identified the terminal, right? We have identified terminal. The terminal, these two have the same reference angle. That's R, right? That's R. Don't forget, from D, so these two are the same reference angles. So we understand that. Okay, how do we represent the angles? How do we represent the angles? Angles are measured from standard position. So we call this is theta. If this is theta, and the other one is what? Negative theta. Okay, so now we're going to represent theta, which is going to be arc cosine negative 4/5. And the solution would be A equals to, you can use theta if you wish, okay, plus minus, and then plus 2k pi. In case any integer. DRA. Okay. I think that's long enough a lesson, and you should be able to do all the homework questions, special and non-special, solving cosine equations. Until next time, thank you for watching.